Let me now discuss another interesting base drive circuit with speed up. Speed up of both turn on and turn off. Let me start with a PNP transistor. The PNP transistor, the collector is connected to a resistance, two resistance divider like this, and from the center point of the resistance division I'll pick off a line and then connect it to the base of an NPN transistor like this. The emitter of the NPN transistor and the collector of a PNP transistor are connected in this fashion. Collector is grounded and the same base is given to this PNP transistor also. And the collector of the NPN is connected to the VCC. So you will see that across this VCC you have an NPN PNP transistor combination connected in this fashion. It's called the totem pole combination. Now when the NPN transistor is on, because the base is more positive with respect to the emitter, the base of the PNP is also connected to the same point. So the base of the PNP is also more positive with respect to the emitter, and therefore the PNP transistor is off. So when the NPN transistor is off and the PNP transistor is on, the emitter is more positive as compared to the base, and the PNP transistor is on, and because the emitter is more positive than the base, NPN transistor is off. So the on and off of these NPN and PNP complements are always mutually exclusive. So there will never be a direct short from VCC to ground. Okay, going further, let me mark that as VCC, and the base drive for this PNP we have already discussed. It is two resistance combination, and at this point here you can give VB, the base drive from a base drive source. Now from this center point of this totem pole, I will pass it through one network R and C combination like this in series, and another in parallel resistor like this, and connect it to the base of the final transistor or the power transistor. The final power transistor is connected to an external load, and IC of that is what is supposed to be switched on and off that we need to control. This is QP. Now let me call this as R1. This is R2. C. This is Q1. This is Q2. This is Q3. R3, R4, R5, R6, VCC. This portion of the circuit, R1, R2, C, now this is the portion of the circuit that we will be calling as the speed up circuit or the speed up network. So in this speed up network, this branch R2C branch is the fast dynamic branch. R2C time constant is having a time constant of the order of turn on times and the turn off times of the QP BJT. So during transients, during turn on and turn off, R2C branch is very active. And during the steady on time, R1 is the active branch. So let us see how this operates. Consider now this point here is the pole voltage VP. Now consider the state when Q1 is off. So when then Q1 is off, there is no current flowing through in this direction. QP is off. So QP is in an off state. Now at this stage, let us switch on Q1. How do we switch on Q1? Q3 is switched on. How do you switch on Q3? Make this low. So when you make this low, there is a possibility for current flow like this. So you have IB on flowing like this, IB on flowing like this, and then you have Q3 on. When Q3 is on, there is a drive current flowing through R3 into this branch here, and it is flowing in this direction. Q1 is on. Q1 is on, Q2 has to be off. So when Q1 is on, there is a drive current that can flow through into the speed up network. So how does the drive current flow? Let us say a drive current flows like this, and through this R2C network in this fashion. So, because initially when the Q1 is turned on, the capacitor C acts like a short. R2 is much smaller compared to R1. Major portion of the current flows through like that, in this fashion, through the R2C branch. There is also a parallel division. Current flows through R1 branch also. But the current through R1 branch is lesser than the current that is flowing through R2 branch. Then as time progresses, this exponentially decay in the R2C branch, because C gets charged up plus minus, and when C gets charged up plus minus to VCC, the current through this branch ceases, and it is only the current through this branch that flows, and this should be the steady on state current. So let us say plus minus the C charges in this fashion, and let us draw the time waveform and see how it looks. Let us say this is IB current flowing in through to QP. How does this waveform look like? We'll plot IB. So IB was 0 during the time Q1 off. When Q1 was turned on, there is a surge here. So that surge is IB on, which is flowing through R1, plus there is a surge due to R2C branch. So let us call that one as IB plus. So from IB plus, there is a steady decrease because C is getting charged plus and minus, and gradually this branch will not conduct current, and only this branch will conduct current. So whatever the steady on current is flowing through R1 will be IB on. And then again during switch off, turn off, now Q1 is turned off. You make this high, VB is made high here, Q3 will turn off, and Q1 will turn off, and because of that Q2 here will now turn on, because C here is having positive charge, this is positive, and the base of Q2, the PNP, is now connected through R4 to ground, which is at a lower potential. So there is a possibility of current flow through like this and current flow through like this. So you will see that Q2 will turn on, and there will be a current flow through Q2. So we will call this IB plus, and this is IB on, and then during the time when Q1 is being switched off, we will see that current starts flowing in this fashion, down through like this, starts flowing like this, and through in this direction, so that the base charges start recombining and comes back and completes the circuit here. So this is the negative current. So this is the negative current that we are seeing that needs to flow through QP, so that QP turns off as fast as possible, and there is base charge recombination. So this point here, we'll call that one as IB minus. So this current which will flow through starts with IB minus and gradually exponentially decay. The charge on this capacitor starts decreasing. So as the capacitor charge starts decreasing, the current here starts decreasing in an exponential manner. So the current will decrease in an exponential manner to 0. So once this decreases to 0, all the base charge has been recombined and QP has regained its off state. So here we know how to design R3, R4, R5, R6, the two resistance drive. The new part is this network. So let us calculate R1. R1 is supposed to handle steady IB on current. So let us say during the steady IB on portion, the potential on this side of the R1 VP is VCC minus VCE sat Q1. That is this point. So we will write that down, VCC minus VCE sat Q1. And on that side you are having VB sat QP. VB sat QP. The whole divided by IB on current. This will give you the value of R1. R2 needs to be much smaller than R1, so you use a constraint, let it be 1/5 of R1. Then in order to calculate C, we know the time we should start with the time constant R2C. Tau which is the time constant is R2C. Now how do we choose that tau? Now this is the turn on time, this is the turn off time. So the turn off time, let us say, is comprising of storage time plus fall time. Turn on time is comprising of rise time. So look into the data sheet of the QP BJT and choose tau comparable to the turn on or turn off times of the BJT. So let us say you have TS storage time and you have TF fall time. TS plus TF, T fall can be fixed as the time constant. R2 is known and C you can calculate. So C can be calculated in this manner. So by making tau, the time constant, smaller and smaller, the speed up can be made much faster. So this is the base drive which has both turn on speed up and turn off speed up. And it's an interesting base drive circuit, and this affects only that portion of the network, base drive network, just immediately before the main power transistor. Then following that you have this totem pole. Following that all the sections, and if you have still more further multi-stage sections, all will be just like as we discussed before, 2 resistor NPN PNP combinations. You have a 2 resistor NPN drive and a 2 resistor PNP drive alternately coming into the picture to form a multi-stage drive with speed up.